Unit 5 test review for dealing with imaginary numbers, quadratic equations. First one I have, show the first 8 exponential solutions of I. So here, we're going to just list out, I to the first power is I to the second power, -1, I to the third power, -I to the fourth power is 1, and then it just repeats, I, 1, -1, I, 1. Here to simplify, I to the 601st power. I to the 601st power. So the first thing I'm going to do is I'm going to do 601 divided by 4. And we go through and we punch that in our little handy-dandy calculator. And after we do that, we get that it is 150.25. The only thing that I'm concerned with at this point is the 0.25. 0.25 is 1/4. 1/4 is I to the first power, and I to the first power is I. So I to the 601 is just I. For problem number 3, here we have to go and set the real portions equal to each other. So 8x is equal to 48. 8x equals 48. And then I got to set my imaginary portions equal to each other. So 4 is equal to -36i. 4 equals -36y. Now I need to solve for x. To solve for x, I'm going to take and divide both sides by 8. And I find that x equals 6. To solve for my y, I divide both sides by -36. I'm trying to isolate the y. Therefore, I have y is equal to a -1/9. Looking at number 4. Number 4 says multiply and reduce in lowest terms. So here, we're going to be doing FOIL. So I'm going to multiply my first two together. 3 times 6. 3 times 6 is 18. Then we're multiplying my 3 times my -4i. So that gives me a -12i. Next, I'm going to multiply my -2i times my 6. That gives me a -12i. Next, multiply my -2i times my -4i, which gives me a positive 8i squared. My 18, he's going to be just chilling out front. I'm going to go through and collect my like terms. These two get added together. So that becomes -24i. Here, remember that I squared is really -1. So 8 times -1 turns that into a -8. I now can combine my like terms of 18 and -8. So my final answer is 10 minus 24i. For this next one, we have to go through and multiply the top and bottom by the complex conjugate. So I have 3 minus 2i over 4 plus 3i. My complex conjugate goes out here, my magic 1. I'm going to put 4 minus 3i and 4 minus 3i. Now we're going to go through and apply FOIL. In applying our FOIL, we're going to have 12 minus 9i minus 8i plus 6i squared over 16 minus 12i plus 12i minus 9i squared. And then we simplify the top and the bottom. Remember, this one right here actually becomes a -6. So I have 6 minus 17i over These two are canceled, and this one here becomes a plus 9. 16 plus 9 is 25. And there's our final answer. For number 6, we're supposed to go through and solve by completing the square. Well, the first step is already done for you. I need to figure out what goes into my blanks here. Well, I have to take my b, so I'm going to take 9 and put it over 2 and square it. So that gives me 81 over 4. So the left side is x minus 9 halves squared is equal to 81 over 4. I'm going to change this one to 4, so that becomes a negative 68 over 4. So I now have 13 over 4. Take the square root of both sides. So I get x minus 9 halves is equal to plus or minus the square root of 13 over 2. I move the 9 to the other side. So my final answer is x is equal to 9 plus or minus the square root of 13 over 2. Looking at number 7. Number 7 again is solved by completing the square. So I have y squared plus 16y minus 1 equals 0. So first I move my 1 to the other side. So plus 1 plus 1. So I have y squared plus 16y plus blank is equal to 1 plus blank. In my blank, I first divide 16 by 2 and square it. 16 divided by 2 is 8, and 8 times 8 is 64. So I'm going to place 64 in each of these blanks. So I now have y plus 8 squared is equal to 65. We take the square root of both sides. So I would end up with y plus 8 is equal to plus or minus the square root of 65. I subtract 8 from both sides. Y is equal to negative 8 plus or minus the square root of 65. For number 8, it says use our quadratic formula. I first have to put it into standard form. Ax squared plus bx plus c is equal to 0. To do that, I'm going to take and move my 4 to the left by adding 4 to both sides. So I now have 6x squared plus 10x plus 4 equals 0. So I list out my ABCs. A is 6, B is 10, C is 4. And now I plug them into my formula. Remember, I always like to write my formula down. X is equal to the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. When I go to substitute, I make sure I'm plugging everything in the right spot. So the opposite of B, so that's going to be a negative 10 plus or minus the square root of 10 squared minus 4 times 6 times 4 over 2 times 6. So now I do a little bit of arithmetic. Negative 10 plus or minus the square root of, well, 10 times 10 is 100. And here I have 16 times 4, that's 96. And 100 minus 96 is 4 over 12. So I now have x is equal to negative 10 plus 2 over 12. X is equal to negative 10 minus x is equal to negative 10 minus 2 over 12. So my final answers are going to be x is equal to negative 2/3. X is equal to negative 1. For number 9, again, using the quadratic formula to solve. It's already in our standard form, so I need to just gather my ABCs. A is 7, B is negative 4, C is 18. Go and plug it into my formula. X equals negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times 7 times 18 divided by 2 times 7. So this becomes x is equal to 4 plus or minus square root of 16. And here we're going to end up with a really large negative number. So I have 4 times 7 times 18. So that's minus 504 over 14. So I now have x is equal to 4 plus or minus the square root of 488 over 14. So x is equal to 4 plus or minus 488 is the same thing as saying 4 times 122. So that'll be 2 square root of 122 over 14. Looking at my Mickey Mouse ears, I can take a 2 out of all of those. So my final answer is x is equal to 2 plus or minus square root of 122 over 7. For number 10, solve the inequality and graph the solution set. Here, we would go through and first find my vertex. My vertex is the opposite of b over 2a. And then f of the opposite of b over 2a. So here I'm going to have my axis of symmetry is just the x is equal to the opposite of b over 2a. So my axis of symmetry for this particular one is x equals 2 over 2 or 1. So coming over here, I put a dashed line at 1. To find my vertex then, so I have 1. Now I need to go plug the 1 back into my equation. So I'm going to have 1 squared minus 2 times 1 minus 15 and see what that equals. So that one comes out to be negative 16. So negative 16, I'm going to count by 2's for this particular one here. 4, 6, 8, 10, 12, 14, 16. Do the negative persuasion. So negative 16 is right here. This graph is going to be going up like so. And then we're going to shade everything on the outside of the graph after we test the point 0, 0. 0, 0 is on the inside of the graph. 0, 0 gives you a false statement, so you shade the opposite side as the false statement. Looking at number 11. It says sketch the graph. State the vertex and the y-intercepts if they exist. The vertex. First I want to find my axis of symmetry. Axis of symmetry. That's x equals the opposite of b over 2a. So in this particular case, it's going to be x is equal to negative 5 over 2. So I'm going to go to the right, 1, 2, or to the left, sorry, it's negatives, to the left, 1, 2, and then my axis of symmetry. This is what divides my parabola in half. I now plug that back in to find my vertex. The vertex is going to be the opposite of b over 2a, and then f of the opposite of b over 2a. So I already know that the first part of my point is negative 5 over 2. So I plug that back into my equation. And after simplifying, I find that it is negative 1/4. So I go down to negative 1/4. My vertex is here. To find my x-intercepts, I set my equation equal to 0. 0 is equal to x squared plus 5x plus 6. I can factor this one, so x equals x plus 2, x plus 3. So I have x is equal to negative 2 and x is equal to negative 3. So those are my intercepts. And my parabola looks like this. Moving on to number 12. Number 12, again, the same thing. First, find my axis of symmetry, which is x equals the opposite of b over 2a. So x is equal to negative 5 over 2 times 2, which is a negative 5 over 4, 1 and 1/4. So I'm going to go to the right, or to the left again, it's negative. To the left, 1 and then 1/4. And there are is my axis of symmetry. To find my vertex, remember it's the opposite of b over 2a, and then f of opposite of b over 2a. Whatever value we find for our vertex, for our axis of symmetry, we plug that back in and solve with it. So I go plug this one in, so I have negative 5 over 4. Then I go and substitute. And after I go through and substitute, I find that it is negative 121 over 8. So I go to the left, my negative 5/4. Then I'm going to go down 15 and 1/8. So that would be down here somewhere. Let's say this is our 15 and 1/8. Next, to find my x-intercepts. Find the x-intercepts. We set our equation equal to 0. 2x squared plus 5x minus 12. Using my rainbow method here, I'm going to take and have 0 is equal to x squared plus 5x minus 24. So this 0 is equal to x plus 8, x minus 3. And then divide both of these by 2. So I have 0 is equal to x plus 4, 2x minus 3. So my x-intercepts are at negative 4 and at positive 3/2. So negative 4, 1, 2, 3, 4, place a point, and then 1 and 1/2, place a point. My parabola then will look like so. as always, be confident in what you're doing. Confident in what you're doing, and good luck. I know you'll all do awesome.